In this video, I will demonstrate how to use SPSS to determine whether a 15-minute individual coaching session significantly improves bowling scores using a paired samples t-test. Because the same students bowl both before and after their coaching session design, therefore the appropriate statistical procedure is a paired samples t-test. So our first step, of course, is I open the SPSS and I load the data set, which is the coaching instruction, by opening that and selecting that. So I already have that here done for us. So my next step is I want to verify that I've got my two quantitative data sets, and the first one for game one, or the pre-coaching, and game two is that second game, the post-coaching game. All right, you'll notice here I do have a third column here, which is the difference. And I want to mention that typically one of our first steps that we would do before we even go into running a paired samples t-test is check for normality of the the difference between the two scores. We would then run a histogram to check that there's a normal distribution. However, for the purposes of this assignment, we're going to go ahead and assume that we've met that assumption for normality. So now let's go ahead and get into our hypothesis. I want to do that before I run our data. First, our null hypothesis says that there is no significant difference between the mean pre-coaching score and the mean of the post-coaching bowling scores. Obviously, of course, our alternative hypothesis states that there is a significant difference between the mean pre-coaching bowling score and the mean of the post-coaching bowling scores. So again, we're going to be using a two-tailed test on this. So let's go ahead and run our data in SPSS. And to do the paired sample t-score, we're going to click on Analyze, select Compare Means and Proportions, and then go to Paired Samples t-test. Let's click that. Okay, now in our little box here, we want to make sure that we move our two variables over to the paired variables. So I already have them here, but if they were not, you would see that it says game one. We would select game one, pick this variable and have that here, and then we would select game two, move that over to have that there as well. And we've got too many variables here. Let's remove that one. Got a little ahead of ourselves. Okay, we want to go ahead and click on OK. And our data is dataing. All right, so now you should be able to see our descriptive statistics here. If we go to this first square here, we've got paired sample statistics or descriptive statistics, and game one stands for our pre-test. Game two is our post game after the 15 minutes of bowling coaching. So for our pre-coaching sample, the means is 90 point score with a standard deviation of 13.54. For our post-coaching sample, our game two, our mean score is 94.95. So there's an increase of about 4.95 points. And for that post-coaching games, the standard deviation is 14.32. We'll go ahead and round that up. So next, we're going to look at the paired sample t-test just a little bit down below here. And what we can see here is our t-test. If we go down here, we can see our t-test is a negative 1.685 or negative 1.69 roughly. Okay, with the degrees of freedom of 19, and our two-sided p-value is 0.108. So, and of course, because this p-value is greater than the alpha or significance level of 0.05, I'm going to go ahead and fail to reject the null hypothesis in this case. I also want to talk a little bit about our percentage change or our delta percentage, which gives us a percentage of this difference between the mean scores. So to calculate this, we subtract the game two score from game one score, or game two mean score from game one mean score, divide that by 90, and then multiply that by 100. So that gives us a 5.5% percentage change in the mean of the pre-coaching scores and the post-coaching scores. So, with all that said, what we're looking at here is unfortunately, there's still no significant evidence at the 5% significance level to conclude that a 15-minute coaching session made any significant changes to the mean bowling scores. And although the average score increased by about 5.5%, that's not really a meaningful difference because it could totally be something that's just based on chance or random and not truly can be, related to the actual coaching scores. So I also want to mention as we go down a little further in paired sample effect sizes, we do running this paired samples t-test, we do get a Cohen's d score that tells us that kind of states the significance of the impact there, or the effect size. Now, what we're getting here is a negative 0.377 or a negative 0.38, which would kind of be a small to medium size. However, it's really important to point out that because we rejected the null hypothesis here, and we determined that there was no significant difference, we really can't confidently depend on this Cohen's d size. But for the purpose, so we wouldn't normally report it, but for the purposes of this assignment, went ahead and did that. Okay, so again, I already talked about how this score just is not a meaningful improvement, even though it's a 5.5% difference, roughly 4.95 points from the mean of the pre-bowling or pre-coaching game versus the post-coaching game. We just don't know if that's really a legitimate change or if that's just simply due to chance. So last but not least, I want to go ahead and share with you my results in APA style. A paired samples t-test was conducted to evaluate whether a 15-minute individual coaching session improves students' bowling scores. The scores prior to coaching, with a mean score of 90.00 and standard deviation of 13.54, were compared to scores after coaching, and the post-coaching mean was 94.95 with a standard deviation of 14.32. These results indicated that the increase in bowling score was not statistically significant, with a t-score of negative 1.69 and 19 degrees of freedom, and a p-value of 0.108 of our two-tailed test. The mean difference between the pre and post-coaching scores was about negative 4.95 points, or a percentage change of 5.5% on average. So overall, the findings here suggest that the 15-minute coaching session did not produce a statistically significant improvement in the bowling performance, and that was simply could have been random or due to chance. And that concludes this recording.